A counterexample for the expression secant squared x minus 1 is equal to cosine x over cosecant x is 45. True or false? So if 45 is a counterexample, then that means that 45 will make this false. So let's just substitute in 45 and see what happens. So let's do the secant squared of 45 minus 1 and see how that compares to the cosine of 45 over the cosecant of 45. Okay, let's start with secant squared. Okay, so secant is the reciprocal of cosine. So if I want to talk about secant, I start by talking about cosine. Cosine 45 is 1 over radical 2. How do I know that? It's on the chart. Alright, cosine of 45 degrees is 1 over radical 2. Okay, that means that secant of 45 is radical 2, because secant is the reciprocal of cosine. So I'm just turning this upside down, I get radical 2. Now we need secant squared, so if I square both sides, then I will have secant squared 45 is equal to 2. Alright, because if you take radical 2 and you square it, you just get 2. The radical and the squaring cancel each other out. So this has a value of 2 minus 1. Now, cosine of 45 is 1 over radical 2. Okay, now cosecant of 45. I guess we got to talk about that. So cosecant is the reciprocal of sine. So if I want to talk about cosecant, first I need to talk about sine. So what's the sine of 45? Well, the sine of 45 is also 1 over radical 2. How do I know that? I know my chart. Sine of 45 is 1 over radical 2. That means the cosecant of 45 is radical 2. Okay, because it's the reciprocal of sine. So that means we have the cosine of 45, which is 1 over radical 2, divided by the cosecant of 45, which is radical 2. Okay, now when you divide a fraction by a fraction, you multiply by the reciprocal. In fact, you know what? Let me teach you the shortcut that I always use. If I have a fraction divided by another number, the extra number just goes in the denominator. So if I have a over b divided by c, then that's just going to give me a over bc. Alright, the additional number just joins in the denominator. For example, if I have 2/3 divided by, let's say, 5, then this 5 is just going to join the denominator. Now, if you understand what I'm saying, you can do this in your head, but I'm going to show an extra step. So the 5 would join to the denominator, so this becomes 3 times 5. So this would be 2 over 15. Okay, if you could just do that in your head, go straight to there. So that's what I'm about to do now. So if I have a fraction divided by something else, it's just going to join the denominator and end up right here. So that's going to be 1 over radical 2, but that's just 1 over 2, because radical 2 times radical 2 is regular 2. Okay, so let me clean this up a bit. So at 45 degrees, the right hand side of the equation is 1/2. The left side of the equation is simply 1. 1 does not equal 1/2. So that means that this is a counterexample. All right, it's an example that proves this is not always true. All right, so it's a little backwards to say that, well, this is false, so therefore this is true, but it is true that 45 is a counterexample because 45 proves that this is a false statement sometimes. And that's what a counterexample is.